this is our first unit. We can discuss the first two units. So now, before we have to starting the paper statistical inference, we can discuss about the discrete distribution and continuous distribution. So, in discrete distribution, which can be divided into two parts. First part is countably finite sample space, and for countably infinite sample space. Under the countably finite sample space, there are total four distributions comes under. First distribution is discrete uniform distribution. Second one is Bernoulli distribution, binomial distribution, and hypergeometric distribution. Under the countably infinite sample space, there are positive distribution, geometric distribution, and negative binomial distribution. So total 7 distribution comes under the discrete distribution. So and in continuous distribution, there are total 6 distribution, that is continuous uniform distribution, exponential distribution, normal distribution, gamma distribution, beta distribution, and Cartesian distribution. Okay, so total under the under the discrete distribution, we have to study the 7 distribution. Under the continuous distribution, we have to study the total 6 distribution. Okay, so already we have to know about the distribution. So first we have to discuss the continuous, discrete uniform distribution. Okay, so under discrete distribution, can it's define PMF. Okay, that is probability mass function, and in continuous distribution it defines the probability density function, that is sorry, due to some network problem. Okay, so firstly we have to discuss the discrete distribution, and then we have to discuss the continuous distribution. So under the discrete
सर
distribution
तुमचा
we
आवाज
have to
खूप ब्रेक
firstly
होतोय.
discuss. आवाज येत नाहीये का?
येतोय पण खूपदा ब्रेक होतोय. नीट काहीच वाक्य कळत नाहीये. क्लिअरली ऐकायलाच येत नाहीये काही.
Okay, okay. Discrete uniform distribution. So what is the PMF of discrete uniform distribution? What is the PMF of discrete uniform distribution?
1/n.
Only 1 upon n. And what is the range of this distribution?
1 to n.
x is equal to 1 to up to n, and mean of that distribution is
n plus 1 upon 2.
n plus 1 upon 2, and variance is
N square minus 1 upon 12.
n square minus 1 upon 12. Okay, so this is about the discrete uniform distribution. Okay, now second distribution is Bernoulli distribution. So what is the PMA for Bernoulli distribution?
P of x is equal to 1 equal to P. P of x is equal to 0 is equal to Q.
Yes, yes. PMA for Bernoulli distribution.
P raised to x into Q raised to 1 minus x.
Okay. So PMF is P raised to x into Q raised to 1 minus x, and the range of that distribution is x is equal to 0 or 1, and value of P is 0 to 1. Okay, because of under the Bernoulli distribution there are only two possible outcomes, either head or tail, that is either 0 or 1. So if there are only two outcomes, that is either 0 or 1, that is called as Bernoulli distribution. जिथं फक्त दोनच पॉसिबिलिटीची शक्यता असते तिथं काय असते तुमचं Bernoulli distribution. Okay, then binomial distribution. So what is the PMF of binomial distribution? What is the PMF of binomial distribution?
N C x P raised to x Q raised to n minus.
What is the PMF of binomial distribution?
N C x P raised to x into Q raised to n minus x.
NCX P raised to x into Q raised to n minus x, and the range of that distribution is
0, 1 up to n.
0 up to 0, 1 to up to n, and mean of that is mean and variance of that distribution is
Mean NP and variance NPQ.
mean is NP and variance is NPQ. What is the additive property of binomial distribution?
P of x1 plus x2 S is equal to PS plus Q raised to n1 plus n2.
In general, okay, so if x follows binomial with parameter np, then summation xi follows binomial with summation of ni with n, sorry, p. Okay, so this is nothing but additive property of binomial distribution. If x follows binomial NP, then summation xi follows binomial summation NIP. Okay. Then what is the next distribution is hypergeometric distribution. So what is the PMF of hypergeometric distribution? व्हिडिओ परत ऑफ केलेत सर्वांनी. हायपरजॉमेट्रिकचं पीएमएफ काय येतं?
capital N minus M C small n minus x divided by capital N C n.
And range of that distribution is
0, 1, 2 up to n.
0, 1 to up to n. Sorry. आवाज येत नाहीये.
0, 1, 2 up to so on.
Wrong. Yes, anyone?
1, 2 up to n.
Sorry. Most important part in the distribution is that the range of that distribution, because the value of PMF or PDF depends upon the range of that distribution. So range of hypergeometric distribution is x is equal to 0, 1 to up to minimum of m comma n. Okay, it is correct or yes or no? तीच आहे ना रेंज. Okay, so these are the some countably finite sample space. Then for countably infinite sample space, first distribution is Poisson distribution. So what is the Poisson distribution?
M raised to x upon x factorial.
Yes. आवाज नाही आला. कोणी सांगितलंय सर?
E raised to minus m m raised to x upon x factorial.
if X follows Poisson distribution with parameter lambda, then its PMF is e raised to minus lambda lambda raised to X divided by X factor. Okay. आवाज क्लियर सर्वांना?
नाही येत.
हॅलो
नाही येत सर.
हॅलो
हॅलो.
सर आवाज नाही येत.
नाही येत सर आवाज.
एकच मिनिट. मी जरा नेटवर्क कनेक्शन जरा चेंज करतो. हॅलो येतोय आवाज?
हो येतोय सर.
थोडस आता आजच्या लेक्चरला ऍडजस्ट करा. नेक्स्ट लेक्चर पासून मी क्लिअर करतो. थोडा नेटवर्क प्रॉब्लेम आहे. So Poisson distribution is, and then what is the mean of that distribution?
M.
सेटिंग मध्ये सेटिंग कुठे येतं हॉस्पिटल असतं.
Okay. What is the mean and variance of Poisson distribution?
लॅम्बडा.
आवाज येतोय का?
हो.
जर समजा तुमचं पॉइसन डिस्ट्रीब्युशन विथ पॅरामीटर लॅम्बडा असेल तर त्याचा मीन आणि व्हेरियन्स काय असतो?
मीन आणि व्हेरियन्स लॅम्बडा.
Okay. Then what is the additive property of Poisson distribution? आठवते? व्हिडिओ कॅमेरा ऑन करा सर्वांनी. Okay. If xi follows, if x follows Poisson with parameter lambda, then summation xi also follows Poisson with parameter summation of lambda. म्हणजे त्याचं इंडिपेंडेंटली काय असतं? सपोज x1 इज इक्वल p ऑफ x इज इक्वल टू x1 काय असेल तुमचं? e रेस टू मायनस लॅम्बडा 1 into x lambda raised to lambda 1 raised to x1 divided by x1 फॅक्टोरियल म्हणजे x1 प्लस x2 असेल तर इकडे काय असणार आहे तुमचं लॅम्बडा 1 प्लस लॅम्बडा 2. ओके. Then next distribution is geometric distribution. So what is the PMF of geometric distribution?
P into Q raised to X.
P into Q raised to X, and range of that distribution is
0 to infinity.
0 to infinity. Okay, and mean of that distribution is काय असतो mean?
Q upon P.
Q by P, and variance
Q upon P square.
Q upon P square. Okay. Then what is the PG of that distribution? आठवतंय का? P into Q, P into 1 minus QS raised to minus 1. That is P divided by 1 minus QS. काय त्याचा PGF? P divided by 1 minus Q into S. Okay, so PGF of geometric distribution. Okay, then next distribution is negative binomial distribution. So what is the PMF of negative binomial distribution?
X plus k minus 1, k minus 1, p raised to k into q raised to x.
Okay, and range of that distribution is
0 up to so on.
so on पण कुठपर्यंत n m r x plus r x minus r कुठपर्यंत का इन्फिनिटी पर्यंत? X is equal to 0 1 to up to infinity. Okay, then हे झाले सगळे आपले डिस्क्रीट डिस्ट्रीब्युशन. ओके, त्यानंतर कंटिन्युअस डिस्ट्रीब्युशन्स. कंटिन्युअस डिस्ट्रीब्युशन मध्ये आपण कोणते मोठे डिस्ट्रीब्युशन बघणार आहोत? तर कंटिन्युअस युनिफॉर्म डिस्ट्रीब्युशन, exponential distribution, normal distribution, then beta distribution, बरोबर ना? गॅमा आणि काय स्क्वेअर डिस्ट्रीब्युशन. तर हे सगळे डिस्ट्रीब्युशन झालेले आहेत. ओके, आता दिलेला टास्क तुमचा आता कंटिन्युअस डिस्ट्रीब्युशन साठी तुम्ही ते काय करायचे, कंप्लीट करायचे. ओके, नाव shall we start the unit number 1, that is the point estimation. Okay, so in point estimation we have to discuss the basic definition, concept of estimator, then sufficiency, and based upon this we can discuss the illustrative example. Now first basic definition. So first definition is parameter. ओके, मग आतापर्यंत तुम्ही काय केलेलं आहे की आतापर्यंत तुम्ही कन्सेप्ट स्टडी करत आला आहात. ओके, म्हणजे डिस्ट्रीब्युशन मध्ये आपण काय करतो की म्हणजे कोणताही डिस्ट्रीब्युशन, सपोज बायनॉमियल डिस्ट्रीब्युशन घ्या. बायनॉमियल डिस्ट्रीब्युशन मध्ये आपण काय करतो, इफ एक्स फॉलोज बायनॉमियल डिस्ट्रीब्युशन विथ पॅरामीटर एन पी. ओके, असं आपण डिफाइन करतो, बरोबर ना. मग पॅरामीटर म्हणजे काय, कशाला म्हणायचं पॅरामीटर? व्हॉट इज मीन बाय पॅरामीटर?
Statistical constant.
ओके, स्टॅटिस्टिकल कॉन्स्टंट. अजून the constant of probability distribution is called as a parameter. Okay, the population constant, that is the constant of probability distribution of the population, is called as a parameter. That is, suppose if x follows binomial np, then n and p are the parameters. Okay, then if x follows Poisson lambda, then lambda is the parameter. Then second definition is parameter space. What is called what is mean by parameter space? The set of all possible values of the parameter theta is called as a parameter space. It is denoted by capital theta. So this is the notation of capital theta. पॅरामीटर स्पेस म्हणजे काय की जो पॅरामीटर आहे तो जो पॅरामीटर लाय होण्याची जी रेंज आहे त्याची जी रेंज आहे ती काय असते, आपली पॅरामीटर स्पेस असते. सपोज इफ एक्स फॉलोज बायनॉमियल np, देन पॅरामीटर स्पेस ऑफ np इज काय असणार आहे, n इज पॉझिटिव्ह इंटिजर. दॅट इज n ची रेंज आपण x काय घेतो 0 1 टू अप टू n, आणि n काय असणार आहे आपला पॉझिटिव्ह इंटिजर असणार आहे. And the value of p is lies between 0 to 1. Okay, so this is nothing but parameter space. Now next definition is statistics. Okay, आता आपण जाऊया BSc second year 4th semester paper number 8 statistical method second. ओके, त्याच्यामध्ये टेस्टिंग ऑफ हायपोथेसिस फर्स्ट. सो व्हॉट इज द डेफिनेशन ऑफ पॉप्युलेशन?
Totality of objects under the study.
येस, आवाज ब्रेक झाला.
Totality
of objects under the study.
Totality of objects under the study is called as a population. Anyone? Bhosle?
Aggregates of items under study.
Aggregate of items under study is called as a population.
Population.
Okay. So population is nothing but aggregate of items or unit under the consideration is called as a population. And what is mean by sample?
Any part of population is called a sample.
Any part of population is called as a sample. Then if we have to study the paper statistical method, so in this paper the first unit is next third unit is testing of hypothesis. So in testing of hypothesis we have to discuss the basic definition. So in this basic definition we have to study the definition of statistics. So what is meant by statistic? आठवते कोणाला? काय आहे स्टॅटिस्टिकची डेफिनेशन? आठवते का? कोणालाच नाही आठवत का?
Statistic is a collection, classification, presentation, and analysis of data and conclusion.
No, this is the definition of word of statistics. I have asked you regarding to our paper for inferential statistics.
If x1, x2, xn is a random sample of a probability distribution f of x theta, then t is equal to t of x1, x2, xn up to xn is a function that does not involve the unknown parameter theta is called statistic.
Okay. The simple definition of statistic is nothing but if x1, x2 up to xn is sample observation of our data, then function defined on that sample observation is called as a statistic. Okay. So what is the definition of statistic? X1, X2, Xn is a random sample from a population with PDF or PMA Pepex theta. Then any function of sample observation, say Tn, that is the T of X1, X2, Xn, which is independent of population parameter theta, is called as a statistics. Okay. Then what is the definition of estimator? I think we have to given two different concept, that is the what is mean by estimate and what is mean by estimator. बरोबर ना? लेक्चरच्या वेळी आपण टोन क्लिअरफाय केलेले, एस्टिमेटर कशाला म्हणायचं आणि एस्टिमेट कशाला म्हणायचं ते. मग एस्टिमेटर म्हणजे काय आणि एस्टिमेट म्हणजे काय? कोण सांगताय?
Numerical value taken estimate.
काय काय परत रिपीट करा.
Numerical value taken by estimator is called estimate.
न्यूमेरिकल व्हॅल्यू टेकन बाय एस्टिमेटर इज कॉल्ड एज एस्टिमेट. आणि एस्टिमेटर म्हणजे काय?
An estimator is a function of sample values for estimating the population parameter.
ओके. So estimator is nothing but the estimating function of our statistic is called as an estimator, and actual value of a function is computed from a sample is called as a estimate. Okay, so these are the two different things, that is the difference between estimator and estimate. Now we can discuss the idea of point estimation and interval estimation. These two are different things, that is the point estimation is different and interval estimation is different. So in our fifth semester we can discuss only point estimation, and in your sixth semester we can discuss the interval estimation. Okay, so if we study the point estimation, so there are consider properties of good estimator. So there are four properties of good estimator. First one is unbiasedness, second one is consistency, third one is sufficiency, and fourth one is efficiency. Okay, so we can study deeply one by one. First one is unbiasedness, second one is consistency, third one is sufficiency, and fourth one is efficiency. So unbiasedness, which is nothing but which is property associated with estimator behavior for finite n. If the mean value of estimator is equal to unknown parameter theta, then it is considered as unbiased estimator. Unbiased estimator कशाला म्हणायचं? तर आय थिंक तुम्ही ह्याच्यामध्ये प्रोबॅबिलिटी डिस्ट्रीब्युशन मध्ये किंवा एलिमेंटरी प्रोबॅबिलिटी थेअरी मध्ये एक्सपेक्टेशन शिकला आहात, बरोबर आहे? व्हॉट इज मीन बाय एक्सपेक्टेशन? स्क्रीन शेअर केले की सगळ्यांचे व्हिडिओ ऑफ. हॅलो हॅलो, आवाज येतोय ना?
हो सर.
कुठे गेला? सगळे गायब झाला एकदम. एक्सपेक्टेशन म्हणजे काय? तुम्ही फाइंड आउट केले ना, एक्सपेक्टेड व्हॅल्यू ऑफ एक्स, एक्सपेक्टेड व्हॅल्यू ऑफ ए एक्स प्लस बी, एक्सपेक्टेड व्हॅल्यू ऑफ ए एक्स प्लस बी वाय, बरोबर ना? एक्सपेक्टेड व्हॅल्यू फाइंड आउट करता म्हणजे काय करता ऍक्च्युअली? सांगा की. नाही आठवत कोणाला? हा तर FY चा पार्ट आहे ना, बरोबर ना? नाव घेऊन विचारू का मग? सांगा पटकन. कोण आहे चैतन्य काटकर? आत्ता आलाय. अरे बाळा, मी काहीतरी क्वेश्चन विचारलाय तुम्हाला. नाही आठवत का कोणाला? बर, ठीक आहे. तुम्हाला आठवायला आता आपण वेळ देऊया पुढच्या लेक्चर पर्यंत.